Welcome everybody to topics in MPLS. All right, or for MPLS. All right, we're gonna first talk about MPLS basics. All right, and really it's gonna be a little history lesson there. We're into terminology. Don't get scared. It's a huge laundry list, just so you be aware of the terminology that exists. We're gonna get into the LDP or Label Distribution Protocol, which is what we use in MPLS in our interfaces instead of TDP. Okay, that's the older version. MPLS configurations, and then we'll get into MPLS VPNs. Okay, so all I want you to do is think about this. MPLS just not came about, but they're now our certifications, right? From finally, all right, since the last CCNA that they had one paragraph on MPLS, now they have a little bit more on it. So this has been around since 1997. This is when the IATF formed MPLS, 1997. And they didn't release it in the RFCs until 2001. We're in 2016. So it took this long. Okay, and you can look everywhere if you want. And you can see that the information that's there is more cryptic than anything else. They don't know what to agree on or what to do, or what it is or nothing like that. But MPLS is not really difficult to configure, as you're going to see when I show you the configuration. Now, there's the laundry list. It's long, so I'll try to go through this quickly. What does MPLS stand for? Multiple Protocol Label Switching Technology. That's what it does. It creates labels as it goes through when you turn it on. FACT is a forwarded equivalency class. It actually categorizes each particular network or label as it goes through. Your CEF table, Cisco Express Forwarding. This is essential. You saw how I raised my voice there? This is essential. So this must be turned on if it's not, which it is, but you can type it in anyway. IPCEF. Turn that on because that and MPLS must work together. Okay? The routing information base or your routing table. Your forwarding information base is the same thing as your routing table, but only for MPLS. That's the only thing. Your LFIB, your label forwarding information base. Now you take a look at all the labels that exist, right? For every network that's there. You have your label distribution protocol, which actually creates a link to every free connection you're in. Your label switching router. This is what I find funny. LSR. We got to get everything on an acronym. I mean, we're in IT. Everything has to have an acronym. Your label switching router is the one that's running MPLS. That's it. And the ones that's running MPLS is your CE, your PE, your provider, your PE, not your CE, I'm sorry, not your CE, your PE, your provider edge, your provider, and your provider edge. That's it. If it's going to the customer, there is no MPLS running on that guy. Okay? Where am I? Label, okay. LSP, label switching path. Which way is it going? That's all it says. All right. Labels corresponding to a single router and it's locally significant. Yes, and it starts at 16 and there's 1 through 15. All right, so when you get a label, right, the router is going to generate a label for itself. Hey, I'm 16. And then when it pushes it, we'll talk about that in a second, or imposes itself into the next router, the router says, well, you're 16, but I want to be 17 or I want to be 20, whatever the case may be. All right, that's called a swap. We'll learn in a second. And then he pushes his label to the other guy. And the guy says, well, you're 20, but I want to be 21. Oh, wow. But now I'm going to the customer. Now I got to pop the label. I got to take it out because I got to leave it as an implicit null, which is label number 3, by the way. All right, and there it is right there. Implicit null, label number 3. So what we just talked about, the push, is called the penultimate hop pop process. And that's what happens. It pushes the label, then it swaps the label, then it pops the label. As it goes to the router, it pushes, the first one pushes it, then the ones in between swap label, swap, 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 swap. Then when it gets to the last router, gets going to your customer, it's got to take that label out, right? It's just pure IP that's going down to your to your customer edge routers, pure IP. So, but in between, it does this. So that's all that means. The P router means it's a provider router. The PE router means it's a provider edge router. That's the router you're connected to. Hey, that's my provider edge router. I'm the customer edge router, so I'm connected to him. That's what it is, customer edge. Upstream begins at the network that is being advertised. I'm the network that's being advertised. So I am the upstream. Downstream, transmit path downstream towards the network packet you're trying to get to. Okay, so I'm trying to get to that one right over there. So I am the upstream. You're downstream from me. I'm sending you a packet. You see how that works? Okay. So control plane. See upstream. Oh, okay. So I'm the control plane, right? Because you have control plane and you have a data plane. Data plane is the downstream. So no big deal. Terminology. Doubt if you even see this. You'll see some of this, like LSR, LDP, what MPLS is, all these different things, but VRF, virtual routing and forwarding instance. All right, what VRFs are virtual routing tables. You're going to see this when we create layer 3 VPNs, which is very interesting because we're going to talk about BGP as well, and I might as well just say it now, okay? Can you see the books that I'm using? These are the books that I'm using. Nowhere in these books, in MPLS or BGP, it talks theory about VRFs and all these BGP and DMVPNs and all these different stuff, but it does not go into depth at all. So what I'm going to give you is more than what's in that book, because all this information that they decided to put onto there is CCNP, which I find great, because your CCNP is, your CCNA now has a weight to it. Because now you know all the more advanced stuff. But do not think, because the packet tracer that's meant for the CCNA, it does support BGP. Only external BGP though, the 7.0. Okay, but that's it. There's no NHRP with BGP. You have to configure DMVPNs. And DMVPNs, there's theory, no syntax. Okay, it'll show you how to create a tunnel, but it doesn't show you how to create an NHRP, which you need, and multiple GRE to create a DMVPN. So there's a lot of things that you're going to get here that you're not going to find in that book. You'll find it in the CCNP book, but you're not going to find it in the CCNA, ICND2 or 1 book. Okay? Theory. That's okay. That's why Laz is here, to give you the syntax, to give you what you need to know. All right? So, VRS, virtual routing tables. RDs are route distinguishers, which you use when you create a VRF, you give it a route distinguisher. Route targets. You're also going to give it a route target. Why? Because you're going to export information into BGP, which you're going to use as a transport mechanism. And route reflectors. And you use that because, let's say you don't want your provider router when you're doing BGP, you don't want it to participate in this particular transaction. So you bypass it altogether with these route reflectors. Okay? But label distribution protocol. It starts at label 16. 3 is reserved for null. So you can't use 3. Looking at the label within the routers, we're going to go ahead and see how that is. Show MPLS, LDP bindings. Okay, you look at all the things that are there. Show MPLS forwarding tables, like looking at the routing table. Show MPLS LDP neighbors. Hey, who's my neighbor? Is he running LDP? Good to go. Show IP Ceph. That's your Ceph. It's going to show you all the routes that are there. Okay, so you do all these commands. That way you know, okay, what's going on. All right, and here's where your push, swap, and pop happens, right? So if PC1 pings PC2, all right, what's going to happen is information is going to go up here to PE1. P1 is running MPLS from F01 all the way to F11. That's it. There's no MPLS going down this way. So what's going to happen is he's going to push his label to this guy. This guy's going to swap a label and then push his label to this guy. Then this guy's going to say, oh, I can't swap anymore. I got to pop it because I'm going down to a customer edge. So I'm just going to send an implicit null. Naked IP. That's all it is. That's all it is. But you'll see it in the lab. That's all that is. That's all that is. Okay? And here comes the most difficult part of all. Turning on MPLS. Oh my God. So in global configuration, IPsec, you gotta have that on. MPLS IP, you're done. MPLS is up and running. In the interface configuration, you also go MPLS IP. And you want to make sure by doing MPLS label protocol LDP, okay, you want to put that in there. It's optional. You don't have to. There by default, but why not? Right? You want to make sure. All right. Now, what's the difference between LDP and TDP? One is an older technology. Okay, TDP. All right, tag distribution protocol. All right, Cisco proprietary. LDP is a newer technology. It's an open standard, and that's the default on all Cisco routers. But who cares? So is IPsec for version 4. It's on, but just type it. It's not going to kill it. This is it. This is enabling MPLS in your network. Obviously, you have to tweak it. Okay, there's more features to it than just that, VPN, all these different things to it. All right, but just to get the basics up and running, this is it. And for your CCNA, I highly doubt it that you're going to have an MPLS simulation. Highly doubt it. But if you do, hey, you'll be ready. All right. So with that said, I'll see you in the next. All right, welcome everyone. This is going to be your warm-up lab. Take a look at it. Take a look at it. It's GNS3. Yes, I know. All right, you have your PC1, 192.168.1.0. You have your customer edge router connected to your provider edge router using the 10114 network, F10 to F11. You have your provider edge going to the provider, right, 10118, right? This is your label switch router. And then you're going down here to another label switch router, which is your provider edge 2, right, 10.1.1.12, and then 10.1.1.16, going down to your customer edge, finally down to the next network, which is your 192.168.2.0. Okay, so this is your warm-up lab, your, hey, get to know MPLS lab, all right, and how to configure it. All right, not a big deal, so let's get to it. All right, welcome back. We're in our MPLS lab. This is the actual simulator that we're going to be using. Yes, it's not the packet tracer, it is GNS3. Once you get to the higher certifications, CCNP, CCIE, unless you use live routers, the packet tracer up to this point, even the 6.2 version, does not support MPLS and any other higher configuration that you may need. All right, so we are using GNS3. It's a free download. You would just need the real iOS. Unless you have actual routers that you can use, that'll be perfect. Or you know of another, or whatever it is, Boson, whatever it is that you want to download, whatever simulator you want to use. But Packet Tracer does not work for this lab. All right, we came from the terminology. All right, and we used a picture of this particular lab to talk about the different things. One thing I want to reiterate is the different planes, whether it be the IP control plane or the IP data plane or the MPLS control plane or the MPLS data plane, right? And what they create and things like that. Remember, the IP control plane is where your routing protocols exist, right? Which we're going to configure. Even though I know you know how to configure EIGRP or RIP or whatever, or SPF, or you should know by now, we're just going to configure EIGRP, all in the same autonomous system. And then we'll go straight into, we'll make sure that we have connectivity across the board by looking at our RIB, our routing information base, our routing table, and that we have connectivity with everybody. And then we're actually then going to enable Ceph. Remember, Ceph, that's where the forwarding information base gets created in the data plane, the IP data plane. All right. And then after we enable Ceph, we'll enable MPLS. Okay, we'll enable MPLS using the label distribution protocol, which is LDP. All right, which creates what? The label information base. All right, it keeps a database, if you will, of all the labels that will exist in our network. Okay, so we'll go through that, and finally, once we see all those, we'll look at the actual forwarding table, which is the LFIB. All right, which is your label forwarding information base, which is the forwarding table, and that is, you can compare the LFIB to your routing table, right? In EIGRP, you have what? You have feasible successors and successor routes, correct? Well, the successor makes it to the routing table. Those are the best path, right? And if we're using MPLS, we're looking for a best label switch path. So those are the ones that go into the forward. Think of that as your forwarding table, right? Those are the winners. Those are the ones that came as the best way to go to the destination. All right. Right now, all we have is just IPs on these routers. Let's go into the customer edge router number 1. All right. And as you can see, if we take a look at the show IP int brief, show IP in brief. All right. All we have is a bunch of IPs on an interface. So let's go ahead and configure EIGRP. So we're going to do config T, router, EIGRP, and we'll just use the autonomous system 100 just to use a number. All right, network 192.168.1.0, right, class full, boundary, and 10.0.0.0, and we obviously need to put the no auto summary, even though it is an advanced distance vector. All right, and then we're just going to do WR on that. We're going to go ahead and close this. That's just me. That's just the way I work. All right, and I'm going to open up P1. All right, let's move this over to the middle of the screen. And again, we're going to do router EIGRP 100. And then we're going to do net. And it's only one statement, really. No auto summary. Do WR. Those neighbors, they should be making quicker adjacencies than that. All right, but let's see what happens. Router EIGRP, net 10. Okay, no auto summary. Do WR. Okay. And then we'll go to P1 console. Bring it down to the middle so we can see what we're doing. Okay, so we go config T, router EIGRP 100, net, class full, no auto summary, do WR, go to PE2, exit once here, router EIGRP 100, net 10, right? It's the class full boundary. So all we have to do is just that one statement. That's why we also put the no auto summary command. All right. And then we go to our last router, which is our customer edge router number 2. And let's go ahead and router EIGRP. EIGRP. Okay. 100. Nets, here we got the 192.168.2.0. And we also have the 10.0.0.0. Whoops, net. All right. 10.0.0.0. No auto summary. Do WR. Well, let's take a look first, right from router 5's perspective. Let's take a look at the routing table. So how we do that? Show IP route. You're very familiar with this command. And there you can see that we're getting updates from the 1.0 network. So we should be able to ping, let's say, that gateway 192.168.1.254. And we're good to go there. So we have reachability across the network. That's awesome. Let's see. Let's pick another number just to check. Let's pick 10.1.1.10. 10.1. Oops. 10.1.1.10. And we're good. So we're good. We have reachability now across our entire network. All right, we can get from one router to the other router. So obviously we should be able to ping from the PC. Let's go ahead and go to the PC just to verify the PC. Right, we're going to ping 192.168.2.1. And do I have a PC already opened? Because that's usually what happens. And of course I do. PC1, there it is. 2.1. First one's request timeout. Again, there we go. There's our ping right there. Let's do it again just to make sure. So we're getting from PC to PC. We have connectivity all the way across. Right? We got all our pings from PC1 to PC2. So our routing tables or RIB, it's done for our control plane, correct? So now, and our data plane as well. All right. Now what we need to do is enable Ceph and enable MPLS. And also, we're going to specifically choose the LDP protocol. Even though you don't have to, we're going to. Now remember, the customer edge routers do not play. You do not configure that on the customer edge routers. You only configure that on the provider routers. That's why you see that the PE1 and P2 and the P1 are LSR, label switch routers. So let's go inside P1. We'll go to the console. And let's go to global configuration. Let's put this, it should be in the middle there. There we go. And we're going to do IP, Ceph to enable it. And then we go MPLS, IP, enter. Now we have to go into the interface. Well, which interface are we going to enable it on? On the F10, not the F11, because the F11 is going to the customer, the F10. So we're going to go interface, F1/0, enter. And then we go MPLS, IP, and then MPLS. Oh, I can't type that out, huh? MPLS, label, protocol, LDP. All right. And I'm just going to copy that. Do WR. And that's it. We're pretty much done with that. That's how simple it is. All right. Yes, there's a lot more configurations you can do to it, and we will be doing more configurations to it later on in the advanced lab. But for just the basics of it, this is all we would need. All right. So we can start label switching. All right, and we're going to do enable IPsec. Because remember, the Ceph table and MPLS work together. IPsec, MPLS, IP. Go inside both interfaces in this router because so it's the provider router within the cloud. Interface F1/1 and MPLS, IP, MPLS, label, protocol, LDP. All right, and then we're going to hit enter there. And then we're going to do just up arrow, F10. And we're going to enable MPLS IP, and LDP. All right, so we did it both on the F/1 and on the F10. All right, so that's good to go there. We'll copy that. Let's go to this last router here, which is the PE2 router. And there we're going to do the exact same thing, but again, only on one interface, which is the one facing the provider 1 router. Okay, so we enable Ceph, enable MPLS globally. We're going to the interface F1/1, MPLS IP, and then MPLS label, protocol, LDP, do WR. That should be it. We should be good to go. All right. So now, if we were to go to PE1, well, let's look at the provider router. All right. Let's take it from his perspective, right? And we go into the console. All right. Let's go ahead and clear the screen of all this gibberish here that we just finished doing. And let's do a show MPLS label, MPLS label bindings. Oops. Show MPLS LDP label bindings. And of course, I'm a little bit dyslexic here. MPLS, show MPLS label LDP bindings. There you go. No. Okay, show MPLS LDP bindings. Okay. So there you can see all the labels, right? Using the show MPLS LDP label distribution protocol, all the labels that get created. You can see that this router gives itself a local tag of 17. All right, it's also giving itself an implicit null because he knows, he is aware of that particular network. All right, he's giving a 17 to the 10.114 network, okay, and the 10.1.1.17, okay, network. But for his own network, the 10.119, because he's connected directly to the 8 network, 9 is right here, so it's an implicit null, so label 3, because he owns it. So you can see that it has all the different tags, 16, 16, 17, 19. You can see all the tags that are there. If you do a show MPLS, and I'm going to question mark this one because I'm not going to go through that again. The forwarding table, MPLS forwarding table. There we go. You can see the tags. It's giving you everything. Here we have local tags, 16. Okay, for this network, we have a local tag 17 for this particular network. We have a local tag of 18 for this particular network. And we have a local tag of 19 for this particular network, right? Which is how to get to this Ethernet network all the way down to the LAN, if you would. Okay, now, but you can see that some say pop. That's going to pop the tag off because you look at 17. What network is that? That's a 10.1.1.4. That's this network over here, which means it has to take off that tag. And the 10.1.1.16 is this one. So it's this network right here. It's also got to take the tag off and just send naked IP down. That's why those say pop. All right. So as we pinged across, right, or it pushed out a label to P1. He swapped it for another label to P2, and P2 popped off the label to send naked IP down to CE2. Okay, so that's what's going on. That's why you see, I have it here somewhere. I never closed it. Router 3, there it is. That's why you see these different things. Looking at the forwarding table, that's how you would see that. Show MPLS forwarding table. Okay, another command that you can see just to look at the neighbors, show MPLS LDP neighbor. And then you can see your neighbors. All right, you have 2 neighbors. You are the provider router. You're connected to 2 networks. All right, your peer is the 10.1.1.17, which is going this way. All right, and then the other one is a 10.1.1.9 going this way. So you have 2 different neighbors that you can go ahead and connect to. All right, and it's showing you who those peers are as far as giving you their IPs, their TCP connection, the state and what they received, that they're downstream, and of course it is the TCP and UDP ports that it's using. Okay, by looking at your neighbors. Now, if you want to look at specifics, you can say show. Let's look at the Ceph table first before we look at a specific Ceph. Here's your Ceph table. All right, so it's taking all those particular networks, all right, 10.1.1.9, 10.1.1.4, all these different networks that are going across, and you see all the prefixes right there of the networks that exist. So it's going to take all those networks and actually in the header give it that label. So that's why MPLS and Ceph work together. But you can specifically, and let's do it from a different perspective of another router. Let's see if I have PE1 open. Well, this is PC2. Let me go back to the lab. Here we go. Go back to the lab. Let's go to console. And we'll look at it from that perspective right there. Do a Control Z, and we're going to do a show MPLS forwarding table, right? But for a specific network, and that network is going to be the 10.1.1.16, and that's a 30-bit. All right, and it's telling you, hey, okay, to get to that network, my local tag is going to be 17, the outgoing tag is going to be 16. You got to go out the 16 network in order to do that. You see how it went straight to the destination. It didn't have to do that. Remember we're talking about the FEC? All right. So the FEC said, okay, well, I just need to go to the 16 network in order to get there. That's it. I know my next hop is 10.1.1.10, but in order to get to the 16 network, which is where I want to go, these are the outgoing tags that I need, which is 16, which is pretty cool. So you can actually see specific information by looking at specific commands. And when you get to these particular configurations, that is what you want to do. You want to type in specific commands to look at certain things. And I'll give you all these commands. You'll see, show MPLS LDP bindings, the one we just did right now, which was, and I'll highlight it, show MPLS forwarding table with the specific network and the bits that are on, or show MPLS LDP neighbor, show IPsef, things like that. Those are the main commands that you're going to be working with, that you're going to be using when you're troubleshooting MPLS. Now, once you start getting to VRFs, there's other commands you'll learn, and you'll get those as well. But this is your basic MPLS. There we go. We've configured MPLS. There's no difference. We still have connectivity across where we want to go. Let's see where PC2, PC1 is not open. That's a good thing. So we can go back to our lab, and then we'll open up PC1, and we're still going to, no, PC1 is open, and PC2 is open as well. So what am I not looking at? Let's go PC2 here. All right, and then we're going to go ahead and ping 192.168.1.1, which is the other PC. The timeout, and there's our reply. So we still have connectivity. The only difference is now it's not using, it's using the routing table, obviously, but now those LSR router says, hey, I have a label. So let's go ahead and put the label inside that header so we can get there faster. Okay, it doesn't have to go and ask every router, hey, which way do I go? Which way do I go? It already knows where to go because it's already prepended within that CEF table. So it knows, boom, then it gets to where it needs to go. That's the basics of MPLS. That's all there's to it. It's very simple. Alrighty, wasn't that bad. We took a look at different commands. We saw the CEF, we saw the forwarding table, we saw the label bindings. All right, you saw enabling MPLS was no big deal. We took a look at the labels. We saw how it popped, right? The implicit null. We took a look at all that stuff. All right, very basic, but now you get the understanding, you get a feel for it. So if you go to an interview, hey, have you configured MPLS? Well, I sure have. The very basics of it, but I've configured it. All right, I know what it does. It's a label switching protocol. It works together with the CEF, Cisco Express Forwarding. So since it pre-populates the header, information goes a lot quicker, right? Doesn't need to look at the routing table. The routing table talks to the CEF table. Hey, here's the label. Go for it. So it knows already. It knows. That's why things move along quicker when you're doing when you enable CEF, number one, and now using MPLS, which is label switching. So even faster. They don't have to look at each and every router. They just got to take a look at the label. Okay? So no big deal. There was your warm-up. See you in the next. Okay, dokie. MPLS Layer 3 VPNs. Boy, we used all the simulators. Packet Tracer, GNS3, and now Virl. All right, we're going to go ahead and create here a Layer 2 VPNs where the IGP is actually going to make the connectivity between the customer edge routers. So let's get to it. All right, welcome everyone. We're in the Layer 2 MPLS or MPLS Layer 2 VPN lab. All right, and what really happens here is that the LDP protocol really it's encapsulating the packets that are coming through, making it possible for all CE routers to communicate via their routing protocol. All right, so it's very simple to configure. So the first thing we're going to do on all the routers, all right, is configure EIGRP. All right, we'll leave the CE routers for last. We'll do first the PE and the LSR routers, and we'll enable MPLS on those as well. And then we'll configure EIGRP on the CE customer edge routers last. Okay, so we'll go ahead and go into PE1, which I already have the terminals open. And we're going to configure config T. Oh, let me click in there. Config T. So router EIGRP1, we'll keep it simple. That's the autonomous system. And then we'll do network, the networks that you're attached to. Now, here's not like the CCNA. We're attached to 3 networks. We're attached to the 10.0.0.4, and we actually use a wildcard mask, 0.0.0.3, all right, when we're doing this. All right, network, net for short, used to it. Network, I'll probably do it for the rest of them, but just to maintain uniformity. 10.0.0.0.8. Again, we're using a 30-bit mask. And then we're using the 16 network as well. Network 10.0.0.0, 16 and 0.0.0.3. And we cannot forget our loopback because we do have loopback addresses. Now the loopback address for the PE routers is all 5s. Network 5.5.5.5 0.0.0.0. Since we're using a 32-bit mask. All right, so we configured EIGRP. Now, when you do wildcard mask, there's really no need to do a no auto summary. This is just me, all right, that I like doing it. All right, but once you put a wildcard mask, you're actually telling it, hey, this is the interface, this particular network that I want to participate in the routing instance. All right, so that's done for PE1. Since we're here already, let's go ahead and configure MPLS. So we need to be in global configuration. So MPLS IP, and then we're going to do IPsef. Now IPsef is on by default for version 4. So, but we're going to go ahead and type it in anyway. It doesn't hurt anything. But we also got to remember, we got to go to the interface. Which interface? In this case, will be G03, that is facing towards LSR1. And we're going to do MPLS IP. And then, even though I don't have to do this next syntax, I don't have to do this next command, MPLS label protocol, I'm going to tab that out, LDP, because the default is LDP, but I like to type it out anyway. I'm going to do WR on that one. Okay, so we're going to go now to our LSR number 1. All right, so be very careful where you're at, that you're doing your configuration exactly. All right, now here we have 3 interfaces that we need to configure MPLS on, and of course the routing protocol and the networks that we're attached to. So config T, let's do a routing protocol first. Router EIGRP1, remember, same autonomous system. Let's do the 8 first, 10.0.0.0.8. All right, and it's 0.0.0.3. Okay. It will help if we put in the net command 0.0.0.8, 0.0.0.3, okay, and then we'll do a net, and you can see we build an adjacency immediately. Okay, so we can do net 10.0.0.0.12, 0.0.0.0.3, and if you wonder how do I know that I'm attached to these networks, well, it's in my drawing, and I have it right in front of me to make sure that I know the networks and I know the IPs. And then the last, well, not the last network, but the next network is the 20 network, which is net 10.0.0.20, 0.0.0.3. And we do have a loop back here, which should be all 6s. Net 6.6.6.6. And then 0.0.0.0, because we're using a 32-bit mask. Okay, so and obviously I'll always do the no auto summary. It takes it by default, just no ow. All right, I didn't tab it out. And then we make sure that we enable MPLS, always globally. And then we do IPsec. And you can see that I already created an LDP neighbor relationship. IP, the interface, which is interface G01, interface G01. And then we're going to do MPLS IP, MPLS label, protocol LDP. All right, and then we do G02, change that, MPLS IP, and then MPLS label protocol LDP. And then we have the G03, and then boom, MPLS IP. And I'm up arrowing, all right, just to make things go a little quicker. It's the same command, it's no big deal. All right, and if we were to look now at show, let's hit enter, have a nice clear, show MPLS interface. Now we see that all our three interfaces are running LDP protocol, okay? And if we look at our routing table, show IP route, we see they're already getting updates from the 4, we're getting updates from the 16, and we're getting updates from the loopback, which is 5, that's running on PE1, okay? So let's go to LSR2. All right. All right, so we're already in global, that's nice. Router, EIGRP, 1 network. So what networks are we attached to here? We're attached to the 12, the 32, and we also have a loopback. So net 10.0.0.12.0.0.0.3, and then we have net 0.0.0.32. No, sorry. How about the network first? Last 10.0.0.32, and the wildcard mask of 3. And then we have our loopback, which is all 7s. Net 10.0.0.0. Whoops. I said all 7s, didn't I? 10, 7. Well, no, we're doing the 12. I'm sorry. 10.0.0.0.12. 0.0.0.3, brain's thinking faster than the fingers. And then net all 7s. And then obviously 32-bit mask. We have that. Always, I put the no auto. I'll tab it out so you can see it. Not that it's necessary once you put in the wildcard mask. And then we'll go to global, configure MPLS IP. And then IPsec, even though it's on. All right, but just so you know that they must be working together. Interface G01. There's only 2 interfaces we need to configure here. MPLS IP, and then MPLS, and you can see, I didn't trust my typing. I hate that. MPLS label protocol LDP, and yes, I did tab my way through there. And then we'll do G02. Change that to a 2. Up arrow, MPLS IP, hit enter, and then MPLS protocol LDP. So we're done there. All right, we'll go to now LSR3, which should be this guy right here. All right, so let's log in. Enable, obviously a Cisco, all lowercase. Global configuration, MPLS, let's do a running protocol first. Router, EIGRP, and then it's 1. The networks that we're attached to LSR3 are the 32, the 28, and the 40. So 10.0.0.0.32, 0.0.0.3. All right, so we'll build an adjacency. So let's wait for that so I don't get interrupted again. I'm going to up arrow. I'm going to change that to a 28 instead of a 32. Oops. There we go. And then a 40 instead of a 28. Those are our 3 networks, plus our loopback that we're going to put in a second. And this one should be 8. So net, because we have 5 for the PE1, 6, LSR1, 7, LSR2. LSR3 would be 8. So it'll be 8.8.8. okay? And then all zeros. And just for good measure, we'll put in the no auto summary, not that we need to at this point. All right, do WR. I always like to save just in case. All right, and then we exit one time, go to global, MPLS IP, IPsaf. The interfaces that we need to go into is the 01, the 02, and the 04. All right, so int G0/1. All right, and enable MPLS there, MPLS IP, MPLS, and again, we get interrupted. MPLS IP is already there, label, protocol, LDP. Now we're going to go into G02. All right, MPLS IP, let's type that in. MPLS LDP protocol, LDP, great. And then we'll do G04. All right, MPLS IP, and then the protocol that we specifically want. All right, do WR. We're done there. Let's go to LSR4. All right, and we need to log in. Enable. Now, it's Cisco. Yeah, I'm ahead of myself. Config T. And then the routing protocol, router. EIGRP. Oops, forgot the autonomous system. 1. Now, in this case, LSR4, we're attached to the 20 and the 40, and of course the loopback. So net 10.0.0.20.0.0.0.3, and we should build an adjacency. There we go, because it's attached to LSR1. So the next network is going to be 40. And that should build an adjacency. There we go. And now we're going to put it in our loopback, net. And it should be 9. Okay, all zeros. All righty. And then for good measure. All right. And then we'll go ahead and enable MPLS on this one as well. Let's go ahead and finish that. Okay, we're in global configuration. MPLS IP, IPsaf. All right, and then we're going to go ahead and 2 interfaces, the G02 and the G01. So int G0/1 MPLS label, or MPLS IP, I should say, first. And then MPLS label protocol LDP. And it already knows, that's why I didn't get an error when I didn't type the P. So we're going to up arrow, go into our next interface, which is 2, and do an MPLS IP there. And then, oh, I hate when it gets interrupted. All right, and then the protocol itself that we want. Come on now. All right, so let's just type it out. MPLS label protocol LDP. All right, DWR. So those are cloud routers. Now we go to our PE2. Oh, I have it open over here. Our PE2. I'm going to enable that. Cisco. And then we're going to go into global configuration. We're going to do the routing protocol, EIGRP 1. Net. Now the networks we're attached to this is the 28, the 24, and the 36. So let's go ahead and start with the 24. 10.00.24, 00003. Not going to get an adjacency yet because we haven't configured that CE2. 28 will be the next one. We should be able to build an adjacency there. Okay. And then 36 would be our next physical network. Okay, and our loopback here would be 10. So net 10, 10, 10, 10, 0, 0, 0, 0. and then no auto. Again, good measure, no need for it. Do WR, again, just to save. We're going to exit. We're in global configuration, MPLS, MPLS IP. Now remember, you're on an edge router, so you got to be careful where you enable MPLS. IPsec, again, it's already on for IPv4, but still, no big deal. And now we're going to go into the interfaces. Which one? There's only one, G01, which is facing back into the cloud. So interface G0/1, enter, MPLS IP, MPLS label protocol LDP. All right, do WR, Control Z. All right, so we got our PEs and our LSR routers already set up. So all we need to do in our CEs is really just run the routing protocol. All right, just run the routing protocol. So let's go to CE1, which I believe should be this one right here. All right, we're going to enable Cisco config T router EIGRP1 network. Now I'm attached to the 10.0.0.4, 10.0.0.0.4, 0.0.0.3. Should build an adjacency. And then I'm going to go ahead and put also my loopback for that one, which is all ones network. 1.1.1.1, 0.0.0.0. Enter, and then no auto. Again, not needed, not needed. Okay. So we're good there. We'll check the routing tables when we're done. Let's go to CE2. CE2 is somewhere back here. There we go. All right, so enable. Okay. Cisco conf T router EIGRP 1 network. I am attached to the 10.0.0.24, that is the physical network, and should be able to build an adjacency after I put the wildcard mask, and we do. And that will be all 2s for the loopback. Net 2.2.2.2, all 0s for the wildcard mask. Okay, DWR, and we're done with that one. We'll go to CE3, which should be, I believe, right here. No, that's LSR1. So LSR2, LSR3, LSR4, P2, CE2. CE2 I just did. C4, oh, I don't have CE3 open, so let's go ahead and download into that one. So we're in CE3, CISCO for Cisco. And now we're going to go ahead and go to global, do our routing protocol, which is EIGRP. And we'll just use one. Network that I'm attached to there will be the 16, and my loopback is all 3s. 10.0.0.16, 0.0.0.3. All right, I should build an adjacency there. And then net, and that's going to be all 3s, 3.3.3.3. 0.0.0.0, 0.0.0.0. All right, and no auto hyphen summary, WR. I always like to copy. Now C2 we do have open right here. There we go. And I believe we already did that one. Router EIGRP, the 24 network, the 2 network. Okay. Okay, lovely. And now, so all we need to do is CE4, which should be this one right here. Okay, so enable Cisco config T, and then router EIGRP 1 network. Okay, network, and I'm attached to a 36, 10.0.0.36. And 0.0.0.3. Build that adjacency real quick there. There we go. And my loopback for this one will be all 4s. Net 4.4.4.4, 0.0.0.0, no auto, enter, DWR. And from right here, let's go to privilege mode so we can check our routing table. I could do a Control Z, but I'm just gonna exit all my way out. Let's get a clear screen, show IP route. And as you can see, I'm getting loopbacks I've been getting IP addresses all the way down from the one network. Let's verify that. Ping 1.1.1.1, which is a loopback all the way on CE1. Okay. .1.1.1. There we go. And I have a successful ping. Let's ping 3. 3.3.3.3, and I have a ping, and then we'll go up arrow again, and we'll ping the 2, the loop back on 2, 2.2.2.2. So we have full connectivity all the way across. But one thing that you may want to do is you want to do a trace route, okay? And let's say to that loopback 1.1.1.1. And what you can see that it's doing the label exchange. So it's going through that MPLS network. It's being encapsulated inside that particular protocol, LDP. And this is what is considered a layer 2 MPLS VPN. I hope it was informative. Thank you. All right, that was a little bit of work. There's a little bit of work there. The IP addresses, the IGP, then MPLS. All right, then we went to the CE routers, did the IGP there, but you saw that we had connectivity, and now the LDP protocol is the one that's carrying across this particular backbone right here. So again, not such a big deal. All right, it is a lot of work, not a lot of work, but some work. You got to pay attention to what's going on, okay? Because if not, you may make a mistake, but we got it to work. See you in the next one. All right, this is your MPLS Layer 3 lab. Now, as you can see, we have PEs. This is going to be your backbone right here. All right, you have your CEs coming down here, but now we need to start creating VRFs all over the place. Okay, VRFs for this particular router, VRFs for this one, because each one's going to be its own subnet. So it's got to have, we're going to be configuring an IGP, we're going to be configuring BGP, we're going to configure a whole bunch of things. So let's get to it. Take our time. All right, here we are in our Layer 3 VPN lab. All right, it's a little smaller than the Layer 2 VPN. You saw that was pretty simple. We just had to just configure a routing protocol in all our routers. And we made adjacencies, and it was going across an MPLS network where the LDP protocol actually took that and made it go across from one CE to the other. Well, really, the CEs made adjacencies through the protocol, through the LDP. Here, what we're going to do is Layer 3 VPNs. Now, when we configure Layer 3 VPNs, there's things that you need to do. Not only do you configure a routing protocol, and here we have EIGRP as our routing protocol, and we do show IP. Let me click on here. Show IP protocols. All right, we have EIGRP1. All right, that's going to be routing for our backbone network, which is right in here. Okay, this is going to be configured right in here. We also have MPLS that's going to be running in that backbone network as well. So you have to make sure that you have show MPLS interface, and you see that in this particular router, PE1G03, it is running MPLS. But let's go back to show IP protocol. Let's do up arrows. All right, you can see our EIGRP, all right, for our backbone. But we want to be able to communicate with our CEs. So RIP is the one that's actually going to be running on the CE and on the PE. All right, it's going to be running on both. So we have that routing call protocol is RIP. Now that's version 2, obviously, not RIP 1, but RIP version 2. And you can see here that is being redistributed. Redistributed into who? Is being redistributed into BGP, because we also have BGP that it is configured, but it's configured as route reflectors. Since it's such a small network, I really didn't want to do any kind of real peering between the provider router. I just kind of skipped it and did a route reflector here and a route reflector here, and made these two routers, these two PE provider edge routers, peers of each other, using route reflectors. As you can see right here, that I am a neighbor of the loopback 777, which is this router right here. But RIP is being distributed into BGP, and BGP is being distributed into RIP, and you can see in their address families for IPv4 and VPN v4. And obviously when you're doing this, you need, and I'll do a show start so you can take a look at it, you have to create something called VRFs, and here they are. Okay, these VRFs are routing tables, right? They're virtual routing instances or virtual routing tables. You have the global routing table and you have the virtual routing table. What this is saying is basically, hey, CE1, which is this one, is being assigned to a particular interface, because you were to do the command show IP VRF, you will see the CE1 with its route distinguisher that you see right here is being assigned to G01, which is this interface right here. So you're telling the router, hey, any network that goes to the G01 is going to belong to the CE1 VRF, that routing instance. And any network that goes to the G02, all right, which is right here, it's going to go into the CE2 VRF, which has a route distinguisher of 1.2. So actually you have three routing tables going on here. You have your global routing table, all right, as we can see, show IP route, right? But you don't see anything else, do you? And you see a show IP VRF. Which VRF? CE1. Show IP route VRF CE1. All right, and I kept everything in lowercase because the names are case sensitive. The CEs, when you do CE1, whatever the VRF name, it is case sensitive. So I kept everything in lowercase. All right, and you can see right now, because we are redistributing to BGP, you can see the 172.16.2.0 network. Okay, you can see that. That's coming from the other side, which is CE4. All right, so you do see that already via the 777 loopback. Okay, but that's remember, I am on the PE router. This is why you're seeing it. This router will not see anything yet because there's nothing configured on none of these routers besides their IP addresses, and you'll see that in a second. All right, so we said that obviously we need a routing protocol in our backbone. We need MPLS in our backbone. We need to create our VRFs for each interface. Okay, and then we're going to choose a routing protocol. In this case, we chose RIP. That's going to communicate from our PE to our CE to create that layer 3 VPN. All right, and you must obviously redistribute it, RIP into BGP, because BGP is the transport mechanism that's going to take it across, and then BGP into RIP. Then all you would have to do is go into the CE1, which I'll show you now. All right, and you can see show IP protocols. There should be no. Okay, this is something that Viral does. Don't even worry about it. Just live with it. It's on. You can take it off if you want, but it doesn't do anything for me. All right, so I'm going to configure now RIP on this. There's nothing else that's on there. There is no VRS on here. Show IP VRF. There are no VRS on here or anything like that. There's nothing on here besides the IP addresses, show IP in brief. All right, that's the only thing that's on here. All right. So what I'm going to do is I'm going to configure RIP. Config T, router, RIP, version 2, network, I'm going to put the 172.16.0.0, and then I'm going to put the network 1.0.0.0. Remember, this is a distance vector routing protocol, class full, and then no auto summary, do WR. Now, if you were to do and this gives you so much feedback, all right, you're going to do show IP route. Oops, too many R's. Show IP route. Did I do something wrong here? I put show IP router. Okay, show IP route. Are you serious? All right. You see an R. Really, you shouldn't be seeing that R. Okay, but okay. It's coming from the 2 network. Apparently, I have something configured on that CE4. All right, or CE3, because that should be it's 172.16, so it should be, I may have something configured on there. I don't know. We'll take a look at it now. All right, but you are getting a RIP. It's coming from there. Okay, and everything else is local, but you don't see no loopbacks from CE3 or anything like that. All right, so now what we need to do, because PE2 has the same configuration as PE1, so let's go to CE3, which I have up here, and we can see show IP protocols, and it's probably due to the management running protocols there. As you can see, that's why we're getting that particular R from CE3, because there is no writing protocol configured, no RIP anyway, as you can see. And then we have no VRF, show IP VRFs. See, nothing set there. Okay, just the management interface is just the IP addresses. So let's go ahead and configure RIP. Config T, router, and you do it like you normally would. Router, but spell it correctly. Router RIP, version 2, network, and this is going to be the 172.16.0.0 again. All right, because class full boundary, and then the network is the CE3, so 3.0.0.0 class full, and then no auto hyphen summary. Okay, and then do WR. Once that gets configured and all the updates just stop coming along, all right, let's look at our routing table. Show IP route. And now we can see that we're getting the loopback addresses, right, from router CE1. All right, and we're getting the 172.16.1.0 network. So let's try to ping. Just because it's there doesn't mean we have two-way communication. So let's ping. Let's ping the loopback. It's easier. 1.1.1.1. All right, and we get a response. Let's try to ping the other one. All right, I'll do an up arrow. 172.16. That should be 1.1 as well. 172.16.1.1. And we get a reply also. So you can see that we do have CE to CE communication. And if I go to my CE1, which I always forget I have it open, I have it here, and I do an up arrow show IP route. Now I see that I'm getting that loopback address, and we'll just ping it 3.3.3.3. And you can see we have connectivity back and forth. And this, ladies and gentlemen, is your layer 3 VPN. Just keep in mind, now we have 3 different routing tables. We have a routing table for the global instance. Then we have one for the CE1 instance and one for the CE2 in the case in P1. And we have a routing table for CE3, a routing table for CE4. We have those VRFs as well. And then the global routing table. So when you are creating your layer 3 VPNs, you do have to create those VRFs so you can keep them separate. Because it could be that several companies could be sharing the same ISP router, okay? Or, you know, companies within yourself, within the same building, could be sharing that same provider edge router as you see here. and you want to keep them separate, well, the way you do that is not only, you don't want to create 200, you don't want to purchase 200 different interfaces. You create what's called these VRFs, just like if you were to do VLANs. But here I didn't do any sub interfaces, so that's cool. All I had to do was a VRF and assign it to an interface. And that's all there's to that. All right, well, that's it. I hope this was informative. I hope you liked it. And remember, practice makes perfect. Thank you. Whew. A lot of work. Got to take your time, make sure everything gets done right, check everything. But eventually you saw that it worked. We had the CEs talking to each other through their VRFs. BGP was the transport mechanism, and we got things to go across. Okay? So in an enterprise network, it'll be much harder. But hey, as long as you take your time, do it a step at a time, write everything down, you'll be good to go. See you in the next. Welcome back, everyone. Before we summarize the section, remember, this is the CCNA. Yes, it's beefier. You still got 90 minutes. All right? Everything stays the same as far as that's concerned. So do not think that you're going to be configuring every last thing. You'll get print screens, you'll get drag and drops, you'll get multiple choice questions, but understanding the concept is the more important thing. Okay, so when I emphasize something, that could be out there in a multiple choice question, that could be in a drag and drop, know what it is. Okay, definitely you need to know your routing protocols, how to configure that. Okay, and IP addressing and frame relay and things of that nature, VLANs, all that. But for real world scenarios anyway. But don't sweat that you think that you're gonna have to. Oh my God, I got to configure in the VRF and I got to make BGP the transport, so I have to make a route target. No, no. That's CCNP level that they put in here. Okay, it's not even in your freaking book about route targets or anything like that. So don't worry about it. All right, so let's summarize this. Go over it so you'll be one step ahead. Okay, basics, you saw a history. Okay, 2001 is when they finally implemented it. Terminology, this you need to know. Provider edge, customer edge, label switch routers. The penultimate hop pop, meaning I'm going to push or impose a label on you, router. Well, I'm going to take your label and I'm going to swap it. And then I'm going to send it to the next one. And then the next one is going to take that label, says, all right, but I'm going to put my own label. And it's like, oh, I'm going to the customer edge. I got to pop mine. Implicit no. That's it. Okay. And then we talked about the label distribution protocol, and it's the default for all Cisco routers. So just make sure that you're running the LDP protocol. Make sure that you're running the LDP protocol. Do not have both. Do not have both because you'll have a mismatch. All right, so make sure that you are running LDP. All right, when we're doing our MPLS VPNs, you saw the first one, layer 2, was simple. All we really had to do was configure an IGP, which was EIGRP, and then MPLS. And then EIGRP took care of itself. LDP just carried it across the backbone. All right, and then layer 3 is where it got a little bit hairy, where we created those VRFs, okay, and then we did the route targets and all that good stuff, okay. But other than that, you're fine. Understand what we did. The way you can have CE to CE, customer edge to customer edge communication, and the whole point, if you are doing layer 3 VPNs in your own environment, is because you want to separate your customers, right? Because a VRF is a virtual routing table. So you have multiple routing tables within one router, and they're separate from each other. So it's secure, okay? For the most part. So this is the things you need to pay attention to when you're going to take your certification, is like, okay, what are they? What's their purpose? Okay? See you in the next.